Welcome to học tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, a story of history of science in 100 experiments. Today we will read story number 91. Hôm nay chúng ta sẽ đọc truyện số 91, Clocking on to Relativity. It is a well-known prediction of the special theory of relativity that a clock moving past an observer will be seen to run slow compared with the observer's clocks. Time dilation. It is a less well-known prediction of the general theory of relativity that a clock in a gravitational field will be seen to run slow compared with the clocks of an observer in a weaker gravitational field. This is linked to an observed change in the wavelength of light coming from a source in a gravitational field, which is known as gravitational redshift. These predictions were tested in 1971 by an experiment that involved flying clocks around the world in ordinary commercial aircraft. The experiment was carried out by two American physicists, Joseph Hafele and Richard Keating. The idea was to see how the time recorded on moving clocks at high altitude, combining the effects of both the special theory and the general theory, compared with the time recorded by clocks that stay at rest on the ground. It would have been a lot easier for them if they could have chartered a private plane, but because of a limited budget, they had to fly economy class on ordinary scheduled flights. The ultra-precise atomic clocks that they used were strapped to the front wall of the passenger cabin and connected to the power supply of the aircraft. An identical set of clocks stayed at the U.S. Naval Observatory in Washington, D.C., ready to be compared with the traveling clocks when they returned home. Between October 4th and October 7th, 1971, the clocks were flown completely around the world from west to east. After making allowances for various stopovers, changes of altitude and changes of speed made by the aircraft, the team calculated that the clock should have gained between 254 and 296 nanoseconds, billionths of a second, with 2/3 of this attributable to the gravitational effect of being at altitude. The clocks ran faster because of gravity is weaker at altitude. The rest of the calculated difference was due to the effect predicted by the special theory, which added to the gravitational effect because of complications caused by the Earth's rotation. The simplest way to picture this is to think in terms of a frame of reference, stationary relative to the center of the Earth. A clock in an aircraft moving eastward in the direction of the Earth's rotation moves faster than one on the ground, but a clock aboard an aircraft moving westward moves slower than one on the ground. The measured difference was 273 nanoseconds, smack in the middle of the predicted range. The same clocks were then flown westward around the world between October 13 and 17, 1971. The results from this leg of the experiment were slightly less impressive. This time, the time dilation effect from the motion of the clocks was expected to cause the clocks to lose more than they would gain from gravitational effect, producing a time difference of 40 plus minus 23 nanoseconds compared with the clocks on the ground. Because of some problems with the data measurements, this time the team could say only that the measured difference was between 49 and 69 nanoseconds, which just about matched the prediction. But together, the two legs of the experiment confirmed, if anyone had doubted it, that the time dilation effects predicted by Einstein's two great theories were real. A more accurate test along the same lines was carried out in June 1976, involving the Smithsonian Astrophysical Observatory and NASA. A rocket-borne experiment known as Gravity Probe A reached an altitude of 6,214 miles, 10,000 kilometers, far higher than any aircraft, on a flight going almost straight up and down that lasted just under 2 hours. This meant that effects due to the Earth's rotation could be ignored. At the tops of its flight, the payload felt a gravitational influence only 10% as strong as the influence we feel on the surface of the Earth. During the flight, the time recorded on the clock in the payload of the rocket, incorporating a maser, was monitored over a radio link and compared with the timekeeping of an identical clock on the ground while the flight was still in progress. The changing speed of the rocket and its payload was also monitored by the Doppler effect, using a second signal transmitted from the Earth and received and retransmitted by the probe back to Earth. The observations were then compared with the predictions calculated using equations of relativity theory. This time, the measurements matched the predictions to a precision of 70 parts per million, or 7,000th of 1%. Nobody was surprised, but a lot of physicists were very pleased. This is still the most complete and accurate measurement of the gravitational redshift yet carried out. Moving on to the vocabulary section. Prediction, time dilation, gravitational redshift, altitude, stopover, attributable, complication, westward, impressive, payload of the rocket, incorporating, timekeeping. Thank you so much for your time, and I hope to see you in the next story. Bye for now.